Okay, here I have two problems. The top problem is a volume mass problem. So this is volume mass. The bottom problem is a mass volume. In other words, I'm starting with a mass and I've got to calculate the volume. I'm starting with a volume and I calculate the mass. The easiest way to do this is using moles. In other words, let's do the first one. 50 liters of nitrogen, what mass of ammonia will I produce? Okay, so how many moles is 50 liters? So it's going to be 1 mole over 22.4 equals how many moles over 50? Right now, let's do that problem. So it's going to be about 2 point something. So it'll be essentially 1 times 50 divided by 22.4. So let's do that. And that's going to be 2.23. So 2.23 moles. So I start off with 2.23 moles. What mass am I going to get? Well, if I have 2.23 moles here, how many moles of ammonia will I produce? Well, if this is 2.23, isn't this double? Because it's 1 to 2. For every 1 here, I get 2 here. So if this is 2, this is 4. If this is 2.23, this is 4.46. 4.46, sorry. 4.46 moles. Right? So what's the mass of 4.46 moles of ammonia? Well, we know 1 mole. We know that 1 mole is 17 grams. What about 4.46 moles? So it'll be 4.46 times 17 divided by 1, or simply 17 times 4.46 equals, rounded to 76. 75.82, shall we say that? 75.82. So this will be 75.82, is that right? 75.82 grams. All right, let's review what we just did. All right. 50 moles of nitrogen, what mass of ammonia, right? Well, it's at STP. If I can determine the moles of this, so 50 liters is 1 mole over 22.4, x over 50. So do you see, first, that 50 liters represents 2.23 moles? Okay? Now, 2.23 moles. Right. Now we'll do a mole. 2.23, 4.46. Why? 1 to 2. Clear? So 1 over 2 equals 2.23 over x. So it's 2 times 2.23, 4.46. So do you see that I'm going to erase this, I'm going to erase this. All right, do you see that 50 liters gives me 4.46 moles? Okay. Well, 1 mole of this particle, 1 mole is 17 grams, right? Is that true? Absolutely. You could say 2 over 34 if you like, and that makes you feel better. It's okay, but it's unnecessary. 1 over 17 equals 4.46 over x. And that equals 75.82. Okay? So that's your answer. Clear? So 50 liters is 75.82. Easy? Okay, good. I'm going to erase that. And I'm left with this. 100 grams of this, what volume? So let's convert that to moles. 100 grams, so we know that 1 mole of that particle is 2 grams, right? So how many moles over 100 grams? So that's 50 moles, right? 50 moles. So this number is 3 times what that number would be. So what is 50 divided by 3? 50 divided by 3. Oops, syntax error. 50 divided by 3 equals 16.67. Or just 17, but I'm just for round off reasons. Correct? That many moles? Is that okay? Yes? So let's see what we just did. 100 grams represents how many moles? Easy, based on that relationship. Okay. Well, this number of moles is 3 times. It's 3 to 1. So if it's 50, if it's 3, it's 1. If it's 50, it's 16.67. Clear? So that's what we did. So, what volume is that? Well, I know that 1 mole is 22.4 liters. All right, well, I don't have 1 mole. I have 16.67. So what is 16.67 times 22.4? 16.67 or 16 point unrounded times 22.4 equals 373 rounded. Okay, so 373 liters. Okay, I want you to go through these calculations and see how I rounded. You want to maintain, I don't know, don't go crazy. This is 4 significant figures, but 3 is if there's a default setting for the number of significant figures in chemistry calculations, you're always safe with 3. If you want to go a little crazy, you can go 4, but 3 is good. Okay, easy? Yes? That's it. That is mass, volume, and the one we did before is volume, mass. Volume, mass, volume. Okay.